Hello friends, welcome to Circuit Adda, and today we are going to learn how to interface a sound sensor with an Arduino board. So before moving into the video, if you want to know more about the Arduino or if you want to learn about the Arduino and other technologies, please subscribe our channel. So let us move into the content. So before moving into the content, we need to know what is a sound sensor, right? So as you know that the sound sensor is nothing but a mic, right? You can see this mic in your mobiles, right? In your mobile phones you can find a mic, right? The mic just performs the conversion operation. So it will convert your audio signal, right? Whatever the audio signal that it is receiving, it will convert that particular audio signal into an electric signal, right? So the sensor, whatever the sensor we are interfacing with Arduino, the sensors will perform the conversion of physical quantities into electrical quantities, which can be understandable by our development boards, right? So what about the sound sensor? The sound sensor is nothing but a mic, right? So you can see on the screen, this is our sound sensor. So here you can see this is our mic, right? So this particular transducer, we can call it a transducer or sensor. So what it will do, whatever the audio signals that this mic is going to receive, it will convert that audio signals into our electric signal, and this electric signal will be processed by with the help of comparators. And here we are having a pot. Normally pot means the potentiometer, right? We are having a potentiometer here. So the comparator is used for comparing the values, and the potentiometer here will be used for calibration. So the only one thing that you have to remember is, if any of your sensor module is having a potentiometer, right? You can see in the previous one also we are having a potentiometer, right? In the previous one, in previous different sensors, we have the potentiometer, and we had used the potentiometer for adjustment, right? So similarly today, here also in the mic one, so the potentiometer here will be used for the calibration purpose. Okay, so I will show you how we are going to calibrate it, right? So in the previous video, which is on soil moisture sensor, so there also we are having a potentiometer, and in that the potentiometer is used for calibration. Similarly, in this particular tutorial also, in our mic sound sensor also, the potentiometer is performing the calibration operation, right? So how we are going to calibrate this, I will explain you. So be with us till the end of my video. Okay. So now what are the pin configurations of our sound sensor? So our sound sensor, as usual, as all the sensors need the power supply for powering their components. Similarly, our sound sensor also needs some power supply. So for giving the power supply, we are having two pins, the VCC and ground. So positive will be given to VCC and negative will be given to ground, and we are having one output pin, right? So this output pin will be used for collecting the audio signal. Okay, so this output pin will be connected to our controller. So in our tutorial we are using the Arduino. So this output pin will be connected to our Arduino board, right? And this particular output pin here, it will be a digital pin, right? So this output pin will be a digital pin, and it will help in performing the collecting the digital signal, whatever the sound signal that it is receiving, that sound signal will be converted to digital signal. That digital signal will be collected with the help of the output pin here. Okay, and here you are having an power LED. Okay, so this LED will provide you an indication that whether the module is powered on or not. And here you are having a status LED, and this LED will be useful to represent the status, whether it is receiving any signal or not. If you are speaking, and whenever you are giving a audio signal, and if the status LED blinks, that means the module is effectively capturing the audio signal that you are providing it at the mic part. Okay, so this is about the sound sensor. So now let us move into the connection diagram, how we are going to interface this with an Arduino board. Okay, so it's a very simple diagram, as I explained to you in your pin out pin configuration. So this is having three pins, right? One will be the VCC, second will be the ground, and third will be the output pin from which we are collecting the signal, right? So this particular module will be a 5 volts module. So this module requires a 5 volt supply for operation. So what we are going to do, we are using the Arduino's 5 volt supply, and we are giving this 5 volts to the VCC, and the ground of the Arduino will be connected to the ground of the module, and the output pin of the Arduino will be connected to 8th pin or 7th pin or any of the digital pin. You can connect it to any digital pin, right? So from 0 to 13 pins, you can use any of the pin. You can connect the output pin of your sound sensor to any one of these digital pins, right? So very simple connection, right? And today our tutorial is also very simple, but this tutorial is very important for us because in the next video we are going to control a light, right? We are going to control a bulb by using the sound sensor. So this tutorial is very important for us because in our next video we are going to control a bulb or any one appliance by using the clap. Whenever we clap, then our appliance is going to switch on, right? So this tutorial will be a basic for that. So in that tutorial I am just making you learn how to interface the sound sensor. Once you know how to interface the sound sensor, you can control any of your device in the home by just clapping. You can clap and then your device will get turned on, right? So this is about the interfacing part. Okay, so now let us move into the coding part of the sound sensor. Okay, so you can see on the screen now, this is our complete coding part. Okay, so as we are having only one pin, right? Only one pin, because our sound sensor is having only one pin. So that one pin will be used as an input pin for our Arduino. Okay, because we are going to get the sound signals from the Arduino board. So first we are going to define the sensor pin. So I am using my 7th pin. That means my sound sensor's output pin will be connected to the 7th pin of my Arduino, and I am naming my 7th pin as a sensor pin because my sound sensor has been connected to the 7th pin, right? And then I am defining a variable here with the name of last event, right? So this last event variable is defined because we are going to store the time. Because what happens with the sound sensor is when we clap, okay, so from the clap you should to take a time of 25 milliseconds, right? So first what we have to do, we have to capture one initial event as our last event, one initial time as our last event, and then when we clap, so the Arduino is going to measure that the sound that has got from the sound sensor, whether it is having an interval of 25 milliseconds from the previous sound value, and if it is having a 25 milliseconds of interval from the previous event, then it is going to detect this is a clap, and it is going to know that it is a clap. So why we are using the last event? The only thing here is we are going to store the last value on which our last time period on which a sound has been detected by the sensor, and whenever a clap occurs, so the clap will be having a duration of 25 milliseconds. So it will compare our clap duration with the last event. For example, let us consider our last event happened at 25 seconds. Okay, so this 25 seconds will be stored in this last event, right? And then whenever you clap, so that clap will have a 25 milliseconds of duration. So what the Arduino is going to do, it is going to make a difference between the last event time and the clap time, and if it is below the 25 milliseconds, then it is going to know that it is a clap. But if it is having a duration more than 25 milliseconds, then it is going to know that it is not a clap, it is something other noise other than a clap. Okay. So, and then when we come on to the voice setup, so here we are going to define the mode of our pin. So the sensor pin, that means the 7th pin of our Arduino, to which the output pin of the sound sensor has been connected. So that pin should act as an input pin because the 7th pin of the Arduino is going to receive the sound signal from our sound module, right? So that pin will act as an input pin. And then the serial begin will have a baud rate of 9600 because we are going to use the default baud rate. You can increase it as I said in the previous videos also, but for me I am using it as 9600. Okay, so let us move into the while loop. So the initial thing that I am storing is that I am reading the digital data because the sound sensor is going to transfer the digital data to my Arduino. So it is on 7th pin, right? So whatever the digital data that I am getting on the 7th pin, I am going to store it in a variable with the name of sensor data. Okay, so digital read command will be used for reading the digital signal. Because if we are connecting any sensors output on a digital pin of the Arduino, then we are going to get the sensor data on that digital pin. And if you want to read the data from the digital pin, then you have to use the digital read command. Okay, and whatever the data that it is reading, it will be stored in the sensor data variable. Okay, and then what we are going to do now, we are going to write a condition. If the sensor data is high, what happens with the sound sensor is, if the sound sensor detects any sound, then it is going to give a digital signal of 1, and if it doesn't detect any sound, then it is going to give a digital signal of 0. Okay, if it detects a sound, it will do 1. If it doesn't detect a sound, it will do 0. Okay, so when I clap, the clap is a sound, so my sound sensor is going to do 1 only. So 1 means high and 0 means low. Okay, so if the data that I am receiving from a sensor is high, that means 1, then what I have to do, I have to compare the time that the 1 happened. That means if it is a clap sound, so the 1 will be for 25 milliseconds, right? So what I am going to do, I am this the milliseconds will be, so if my sensor, if the data received from my sensor is high, then the next thing that Arduino will do is it will start differencing the time that the data has been received and the last event occurred, and if the difference is greater than 25 milliseconds, then it is going to detect it as a clap, so we are printing it on a serial monitor as clap detector. Otherwise it has to do nothing. Okay, so one very easy command, so you can see here I have written in the command also, if 25 milliseconds has passed since the last low state, it means that the clap is detected and not due to any surplus sounds. Okay, that means if one last event occurred, that means let us consider that previously a clap occurred, and then once the clap has been gone, it will go to low state. Okay, and once the low state has occurred, and again when I clap, so if the duration from the previous low state to my clap is, if it is 25 milliseconds, okay, if it is greater than 25 milliseconds, then we can know that it is a clap signal, right? So what here is, we are comparing this function, is my milliseconds, the time taken for my clap and the time that the last event occurred. So if this difference is greater than 25 milliseconds, then the Arduino is going to detect that particular signal is a clap signal. So immediately it is going to print on the serial monitor that a clap has been detected. Okay, once it displays on the serial monitor, and then what it will do, now the clap has been occurred, right? So it is going to store the clap time as the last event, and then again when you clap, so again it is going to take the difference of the last time clap and the present clap, and if the difference is 25 milliseconds greater than 25 milliseconds, again it is going to print as clap detected, and again the time of the present clap will be stored in the last event variable, and then again when you clap again it will make the difference of the present clap duration and the last clap duration, and it is greater than 25 milliseconds, again it is going to print as clap detected, and the time taken for the present event. Every time at the ending of the code, the time taken for the present event will be stored as the last event, and whenever the new clap occurs, so it will be compared with the last clap event, and then if the difference is greater than 25 milliseconds, then it will be clap, otherwise it will be not a clap, right? So this is a very simple code. Okay, first we are defining our sensor pin, and then we are taking a variable to store the event, and then we are defining our sensor pin as input pin because it has to receive the signal, and then the baud rate, and then whatever the sensor data I am receiving, it will be stored in a variable with the name of sensor data. Okay, and then if the sensor data that I am receiving is high, then high means there is some audio that has been captured by my sound sensor. Then I am going to compare that whether the audio that the sound sensor captured is a clap. So for detecting whether it is a clap, we have to take the difference of the present events time period with the previous events time period, and if the difference is greater than 25 milliseconds, then it will be a clap. If the previous event time period that taken for the previous event and the time period for the present event is not greater than 25, then it will be not a clap, it will be some noise signal. Okay, so this is the very simple code, and whenever the Arduino detects that it is a clap, then immediately it is going to again update its last event variable with the new clap time period, and again other claps occur, then the particular clap time period will be compared with the previous clap, and greater than 25, again the new clap will be stored as the last event. So it is a cyclic process. First it will detect whether I am receiving anything on my sound sensor, so it will be detected with whenever if the pin is high, if the data receiving is high, and if it is detecting some sound, then it is going to check that whether the sound is a clap sound. So for checking that, it is going to compare the present clap duration with the last event, and if the duration is greater than 25, then it will be a clap. and immediately the present clap time will be replaced with the previous claps time. Okay, that means let us consider I have clapped for first time. Let us consider it is deducted at 25 seconds. Okay, and the other clap, so this 25 will be stored as a last event. And again when I clap, so the clap duration will be minus from this 25, and if the duration is greater than 25 milliseconds, and then it will detect that it is a clap, and this time the clap time period that will be greater than 25, that means 30, so that 30 will be stored as a last event, and it will be going to occur continuously, right? So let me show you the connection here. So you can see here, this is my sound sensor, right? So this is my sound sensor, and as I said to you, I have connected my VCC and ground, and then I have connected my one of my thing to the seventh pin of my audio. So this is my complete sound sensor, you can see. Okay, so now let us upload the code to our Arduino board. So for that I am connecting my Arduino with my laptop, and I am checking whether the tools, and I'm going to board. So you can see here the form 15 is my Arduino Uno. So everything is right here. Okay. So and for the sound sensor you don't need any library. Okay. So don't get confused that I am not using any library here. For the sound sensor you don't need any library. Okay. Now I'm clicking on upload and waiting for the code to get uploaded. So the code has been uploaded successfully here. So you can see now I am talking, but my sensor is not able to detect it as a clap because I have calibrated this for the clap, not for my voice, right? So now let us clap it. So let me show you the camera here. Okay. So this is my sound sensor. Okay. So now I am silent. So when now when I clap, it is really like that. Okay. So this is how we can interface our sound sensor and make the sound sensor to detect our clap. Okay. So let us consider if you are not getting the clap here when you are going to perform it, there may be some condition that you are not able to get the clap here. Okay. So I will show you how to calibrate it. So now I have just miscalibrated it. So when I am talking, then also my Arduino is detecting as a clap detected. But I am not clapping right now. But still my clap Arduino is detecting that it is a clap. Okay, so it is because of the sensitivity of your sound sensor. And you have to calibrate your sound sensor properly for rectifying those errors. Okay, so how we can calibrate the sound sensor? So as we have discussed in the TV, we have to adjust the potentiometer position for calibrating our sound sensor. So you can see here my sound sensor is continuously giving the output that I had clapped or something, but I am not clapping, I am talking with you in my video, right? So for adjusting that, what I am going to do, I am taking my sound sensor, you can see here, right? And then I am going to rotate the potentiometer. Okay. So now you can see I vary it. So now you can see when I am talking, my sound sensor is not detecting the as a clap. Okay, so let me clear you the output here. So now I am talking, right? Now I am talking here, but my sound sensor is not detecting it as clap because I have varied the calibration of the sound sensor. Now let us check when I clap, then also it is going to detect or it completely got jumped and it is not going to detect anything, right? So let me check it. So you can see now it is not able to detect the clap also, right? So it happens because we have calibrated it for a higher value. Okay. So now let us reduce our calibration. I have rotated this clockwise. Now I am rotating it in anti-clockwise direction. Okay. And then again I will. Now I am not able to calibrate, right? So I will rotate it again. Okay. Now, you can see now it has been perfectly calibrated, right? So the only thing here you can know is you have to calibrate the sound sensor for your clap signal, right? If you calibrate it for more value, then it is not going to detect the clap as I had done previously. So I am again rotating it is anti-clockwise direction. I will calibrate it for more signal. Okay. Again I will open my serial monitor. So now when I am clapping, I am not getting any of my serial monitor because my sound sensor has not been calibrated properly. So now I will rotate it in anti-clockwise direction. So now let me clap. So you can see here now it has been very properly calibrated. So we have to remember that if you are not getting the clap, if your Arduino is, if your sound sensor is not able to detect your clap, then try to adjust the try to calibrate it by adjusting its sensitivity by rotating this potentiometer here. You first try to rotate it in anti-clockwise direction and clap. If it is not working, then try to rotate it in clockwise direction and again clap it so that it can detect your clap, right? So and sometimes in some of the like here I have detected my sound that when it is high, okay, because my sound sensor that I am using here, it is able to whenever it detects a sound, it will give the high signal. But there may be some modules in which whenever it detects a sound, then it is going to give the state as low. Okay, so you have to check that also. Okay, you have to calibrate it. It will be a important thing. But along with that, after proper calibration, if you are not getting the if your sensor is not able to get the clap, then try to remember the other thing that here whenever my sensor receives a signal, it will give the high. But there may be some sensors when they receive the signals, they may give us the low signal, not the high, right? So that's why I have written in the command that the go slow sound is detected. So this particular comment has been given here to make you know that my sensor detects the signal, then it will give high, but there may be condition that your sensor when detects the signal, it will give low. So you have to check that also. First you have to calibrate it, and after rotating it in clockwise, anti-clockwise direction, then also if your sound sensor is not detecting your sound, then try to change the high to low because because some sensors may give the low when they detect the sound and give high when they don't detect the sound, right? Then you have to make the change here and change this to low. But my sensor gives high when it detects the sound and gives low when it is not detect the sound. So the reverse operation may also occur. So first try to calibrate this by rotating the potentiometer. Then also if you are not getting the value, then try to change the high to low and then check it, right? The code required for this particular interfacing of sound sensor will be provided in the description, and will be provided in the description. There will be a link in the description, so you can click on the link and then you can get the complete code of this particular interfacing part of sound sensor in that description, right? So go to the description and click on the link for getting the code of this particular interfacing part of the sound sensor. So this is for today. So here we have learned how to interface a sound sensor and how to make the sound sensor detect my clapping, right? So in the next video we are going to make a small project, but before going into this project I will make you learn how to use a relay switch. Once we learn how to interface a relay switch with an Arduino, then we are going to make another small project in which we are using the sound sensor, and then and when we clap, then our device is going to on, and when we clap, our device is going to off, right? So for more exciting content, try to subscribe our channel so that you can get more exciting content in the project, because in coming on videos there will be many interesting contents that you don't want to miss, right? So subscribe our channel and hit on the like button if you like our video. So thank you.